I will invite Ana Paula Aparecida Borges. She is a PhD student in chemistry at the University of Catalão. She graduated in the same university, and she also has a degree in agricultural sciences. Right for me. My name is Ana Paula, and together with the professors Marcelo Faria and Professor André Carlos, we are going to be presenting a study that we carried out together with the UF Cat Una Association for the influence of the rock dust for the millet culture. Today, Brazil occupies the fourth position in the production of grains, reaching in the year of 2021 250 million tons of grains. So we do have a very outstanding production position in the world production of grains. Now, about the relation of the composition of Brazilian soils and the need to fertilizers. Brazilian soils are highly acidic, and it needs correction for the soil with good management in order to correct that soil to make available the nutrients for the production. In this case, Brazil depends on the extensive use of fertilizers as NPK fertilizers for the maintenance, growth, and productivity of the plants. This dependency, this extensive use of NPK fertilizers of the Brazilian agriculture depends on importing fertilizer. More than 80% of the fertilizers in Brazil and the inputs used in agriculture, they are from countries such as Russia, Canada, and China, making our country very vulnerable to international market oscillations in fertilizers, in increasing the cost of production. In order to reduce these production costs, one of the alternatives would be to use remineralizers that we have carried out several studies for the use in agriculture with the aim of decreasing essential inputs such as NPK. The remineralizers are rock powder that are rich in nutrients, especially in the waste of mining company, and they are used to increase the fertility of the soil. The goal of this paper is to analyze the rock powder as a fertilizer in the millet crops, and we use vermit as the here we follow the protocol of evaluation, of agronomical evaluation from Embrapa, where we did 6 treatments. Out of these 6 treatments, each one was done the addition of a specific nutrient in each composition with their respective doses. As you can see in the table, we have the treatment from 1 to 6. And in the number 1, we had the control group that we call the testimony. In this one, we did not add any kind of nutrient. In the group 2, we did a full use of NPK, chemical NPK, and in the 3, we added only the rock dust, and in 4, we did the addition of N and P, the chemical N and P, with the association of the rock dust as a source of potassium. And in number 5, we did only the liming of the soil, and in the 6 we did the liming associated with the chemical NPK. Talking about the results of this work, we have evaluated 5 points where in the treatment 1 we can see that we have 2 Two were better than others. That were the number 2 and the number 4. In the number 2, we had NPK, chemical NPK. And in the number 4, we had NP and the rock dust, rock powder. In the other treatments, we did not see a significant evolution, and we can highlight only treatment 2 and 4. So, in treatment 2, in these results, we are talking about the relation of the height of the plant in centimeters with the experimental treatments of the soil. As you could see, in treatment 2 and 4, we had a very high, significant height, and in treatment 2, we have around 77 centimeters of height compared to 4, where we had an average of 91 centimeters of height for the plants. Treatment 4, as you can see, is the one that has the association of chemical NP and the rock dust. We had the significant results when compared to chemical fertilization alone, and that is due to the fact that the chemical NPK is soluble and favors the immediate absorption of nutrients through the soil. Some studies show that rock dust is a nutritional gradual liberation source that will gradually release the nutrients according to the growth of the plant. What may happen here in this difference in these two treatments is that in both of them, actually in all the treatments, we did daily irrigation, and due to this high solubility of the chemical NPK, there might have been losses through leaching, as the remineralizer is a gradual liberation, provides gradual liberation, so it minimizes losses through leaching. So it is able to provide these nutrients according to the growth and development of the plant. In this second evaluation, we observed the number of plants per vase. So here we have treatment 2 and 4 standing out again. We had an average of 5 plants per vase, and in the other treatments we had an average of 3 to 4 plants per vase, showing that the plant needs the NPK fertilizing to proceed with all its metabolic functions for growth and development. This next evaluation, we evaluated the total green weight of the plant, encompassing both the root and the aerial part, right? So it's everything. And we can highlight here the treatment number 4, where we use the remineralizer and the chemical NP. As you can see, we had satisfactory results, and comparing this result with treatment number 2, which is the chemical NPK, we have an average of green weight of 178 grams for treatment 4 when compared to treatment 2, where I have an average of 97 grams. And when we compare these two results with our control, which is the number 1 where nothing was added, we could see an average of 25 grams of green weight, showing a potential of the remineralizer for agriculture. Now, in the next slide, the next evaluation, we evaluated the green weight of the aerial part of the plant alone, just the upper part of the plant, not the root system. And again, treatment 4 stands out for its performance with the use of the remineralizer. We were able to obtain 109 grams compared to treatment 2, which had an average of 57 grams, and our control that was only 13 grams on average. So again, we show that the remineralizer can be used in association with these chemical fertilizers fertilizers to improve the management of crops. In this last data that we have here, we evaluated the green weight per plant per in grams, and again, we have treatment 4 standing out. We had an average of 37 grams of green weight per plant compared to our treatment 2 where we obtained 20 grams and our control where the average weight was 6.29 grams. In conclusion, we can say that this treatment with rock dust, especially combined with other nutrients such as nitrogen and phosphorus, show their efficacy in fostering the growth of plants. These results, they are significant because the treatment that combined NP and the rock dust, it was much better even from than the chemical NPK. So the results suggest that rock dust can be a viable alternative to traditional chemical fertilizers and consequently reduce the cost of fertilizers in the agricultural production in our country. I would like to thank Una Catalão, where I work, that provided us the room to carry out this study, and also UFCAT in the name of Professor André Carlos, who established this partnership with us, and CBFOS for the possibility of presenting our work here. These are our bibliographical references. Thank you very much.
Outstanding presentation. We would like to open the floor to questions. I believe we have 2 questions now. Good morning. My name is Gilson. I am a chemical engineer and I am an expert in processes. My question to you is the following. If the plant feeds itself from liquid mineral salts, how is it going to feed itself with rock minerals? So if plants, they feed themselves from liquid minerals, how is it going to survive with solid minerals from the rocks? Second question. Are there any studies, and if there are no studies, to do percolation with the glauconita penetration into the soil? If there is, what were the results? Regarding the results that you asked from the previous question, I cannot answer that now because I don't have this piece of information with me now. Now, regarding the first question, since this nutrient is released slowly to the plants, what we're going to depend on the size of the particles of the rock dust so that we can have the solubility jointly with the soil and that the nutrients are going to become available to the plant. So we have 120 days of the cycle. What would be the liberation? I'm sorry, I don't have an answer to that question. Thank you very much. One more question. I have a question. I would like some information about the methodology to use rock dust in chemistry and mineralogically speaking. This issue of the rock dust and the mineralogy, I'm going to be honest regarding the study. All of the installation, the experiments, I didn't follow it up closely. I only worked when it came to the writing of the paper. The paper was conducted jointly with Professor André and Professor Marcelo, and talking about more specific information regarding the chemical study, the mineral study. I'm sorry, I don't have this piece of information now. And what was the potassium grade in this rock dust? What was the grade? What was the amount? He can share this information with you because I couldn't get it. Thank you very much. I'm going to help Anna even though she doesn't need it. Between 6 and 8% was the grade that we analyzed because these samples, they were collected from different points. We had the south, the north, the east, the west faces, and so between 6 and 8%. The maximum was 8%. We did the mineralogy, we did everything, all of the analysis, and we're preparing this now. And this was very good in the test, but it didn't reach the results we were expecting. So we have a second phase now. Anna is going to start working with this, and the main topic is potassium. And so we went up to 1,000 degrees, different times of exposure. And I arrived at the end of the experiment. I could only see the final part, so I couldn't follow up the entire development of the experiment. I started my undergraduate studies in agronomy, and so we have been working for 1 semester studying this. Okay, thank you very much. Thank you very much. Thank you, Ana Paula, for your presentation.